Hi everyone, so this next video is an extension of the work on sum of a geometric series, and we're going to look at how financial institutions work out monthly repayments when you borrow money for them, to borrow money for a car or a house or something like that. So let's get straight into the problem here we're going to solve. Jimmy needs to borrow €1,000 to buy a second-hand car. How much will the monthly repayments be if he borrows the money from a financial institution and repays the loan over 18 months at a fixed rate of 4% per annum? So how would we approach a formula which helps us to do this? Well, what we're actually doing then, we're going to call what is borrowing the principal. So we'll just have a nice big P for principal. Now, when you borrow money from a bank, they are going to charge you interest for doing that, and they're going to charge you interest before you make a repayment. All right, so let's just imagine that we know what the ratio is that they're going to charge you. P times R is interest in that first period, and then when they've done that, you can subtract whatever monthly payment that you make, which we're going to call X. And then we're going to repeat that process until the loan gets paid off. So the next time, what we're actually going to do, if I just choose a slightly different color here, this total remaining balance, which is their rate minus your repayment, is going to get multiplied by R again. And then when they've done that, you can subtract whatever your monthly payment is going to be. And that process just repeats. Let's just expand it out a bit so we can start to see what the pattern might be. So P times R minus X times R. Well, that's going to give us P again times R squared minus X times R. And then we're going to subtract the X. Then we're going to take that particular one again. Let's choose a slightly different color. This new balance, and we're going to repeat that process. R to find out what the interest on the new balance is, then take away whatever our payment is going to be, X. So we'll just work that out one more time because the pattern should become clear after that. Right, minus XR and then minus X. And what you should be able to see is that there's a little string of things building up here with a particular pattern. And that particular pattern is minus X, and minus X. And on this side, what you've got is the principal being increased regularly by whatever the interest rate is. So it's in two parts, the part where they are adding on interest and the part where you are adding payments to try and reduce the balance on the loan. So let's just work with this second part here. Let's pull out the negative X that we can see. So we've got PR cubed minus X into whatever this is. This is R squared plus R, right, and then plus 1 at the end. Okay, minus X into minus XR squared is R, minus X into minus XR is R, and minus X into minus X is equal to 1. Next step then, I'll just move up my board a little bit so we can see what happens next. The bit inside the brackets is sum of a geometric series where the smallest term there is a 1. Okay, so we could take this bit inside the bracket and replace it with the formula for the sum of a geometric series. And when we do that, what's it going to look like? Well, if you remember back to our previous videos, what that's going to look like, and be careful how I write it out, this bit, there's minus X PR cubed on that side, my pen is playing up for reasons which I'm not clear. PR cubed minus x, and this bit inside the bracket we can write as Rn minus 1 divided by R minus 1, which you'll remember is a sum of a geometric series. And in this case, the A is 1, so the A which would be here is not visible. So now we have a formula which we can start to work with, because when we pay off a loan, this number here is balanced by this number here, and the balance comes to 0. So what we can write then is that PR cubed is equal to x into Rn minus 1 over R1. That there piece there is not a negative sign, it was me just demonstrating something, so I'll take that out, put my bracket on the end there. And now all we have to do to find out what our monthly payment would be is to separate out x and make x the subject, in which case x is equal to PR cubed times R minus 1 divided by Rn minus 1. And that particular expression is one which is used by banks, and it's the legal way in which your monthly payments, your weekly payments, your yearly payments, whatever they are calculated. So x equals what we might call the period payment, R equals the ratio, so that's going to be 1 plus the percentage rate over 100, and N is the number of periods, however long you want to pay the loan off over. Okay, so let's now apply this to our little problem that we had at the beginning about borrowing some money for a small car. In that example, we're agreeing to borrow 1,000 euros, dollars, yen, whatever it happens to be. We agreed that the rate, the yearly rate, was going to be equal to 4%. So the APR, we're going to come back to that, equals 4%. And the number of periods we agreed was going to be over 18 months, because he feels he can pay it off over that amount of time. Our first step then is to find out what the APR as a percentage is per year as a monthly repayment. And the way to do that is to remember that because we're compounding every single month, we're adding interest every single month, we can't just take the APR and divide by 12. We actually have to find the geometric mean to find out what the period rate is going to be. So the geometric mean is going to be like this. So 1.04 represents the 4%, and we're going to take the 12th root of that, a thing that you can do on your calculator. And if I take the 12th root of that, what I get, if I can just make sure I've got the right piece of paper here, is 1.003273774. Right, lots of decimal places, but we'll keep it like that to make sure our calculations are accurate. Okay, so now we've got all the numbers that we need in order to calculate Jimmy's monthly repayment. So using the formula, which is up here, this piece here, monthly repayment X, we just put all the numbers into this formula here. So X that we're trying to work out is 1,000, right, times, well, let me just say, I make one little modification up here. This bit should be N, not just, that's where I was calculating. So 1,000 times 1.0032737 to the power of 18, big number. That's how much you're going to owe the bank, and we are going to multiply that by r minus 1, which is 0.0032737. So that's this number here minus the 1, and then we divide all of that by r to the n, which is 1.0032737 to the 18 minus 1. And when you put that into your calculator, you should get out of that a figure, if you've done it correctly, of 57.30 euros per month. So that Jimmy is actually going to have to pay that amount out each month to pay off his loan. Okay, so we can actually check that. We can take a look at a completed schedule. I'm going to bring something across now from Excel. Let's just move that 57.30 up to the top, and I'm going to bring across an Excel spreadsheet from the other side. There we go. And inside Excel, there's actually a function for working all this out. Inside Excel, you've got a function called the PMT function, and sure enough there, when you use the PMT function, it comes to 57.30. Here is my capital, 1,000, my interest rate, 4%, my monthly interest rate, right, 0.327374%, right, so that's why it looks slightly different to the one that we've written down. The number of periods is 18, and it tells us that it's 57.30. Now here, I've just written out our little formula that we've discovered into Excel. We can go over that if you need to. But what you see here is that there's a schedule. The schedule says each repayment, which is 57.30, how much interest he's paying each month, and because the balance is going down, he's paying less and less interest each month, and each month he's paying off more and more of the mortgage. And there you go, at the end of the 18th month, he has nothing left to pay. And just for interest, in order to use that, he had to borrow the money, and he had to pay the bank $31.39 for the pleasure of borrowing the money and buying his car. So there we go. That is the formula that gets used. Let me just move this out of the way once more. Bring the formula back down here. It's in the brackets there. And whenever you get asked to work out the value of a loan or a mortgage, this is the formula that you're going to be using and putting numbers into. Or of course, you could just go straight to Excel and use the PMT function, but then that wouldn't be maths, would it? Take care. I'll see you in the next video.